In this video, we are working on this Euclidean geometry, or I think I would like to call it circle geometry question, and we're proving the following. We are proving that E2, which is this angle over here, so we're proving that E2 is equal to D2. So yeah, if you're keen on finding out how we're gonna do that, then I suggest you stick around. But anyways, if you're ever gonna prove that two angles are equal to each other, right? The one thing you want to keep in mind is try not to focus too much on like proving that they're equal directly. Like, don't look for a theorem that's gonna easily make you just prove that these are equal to each other directly. No. What you want to do is you want to find an angle equal to E2 some way, somehow, and then you also want to find something equal to D2. And then once you have done that, you're most probably going to find out that these two angles are equal to the same thing, and that's how you're going to show that they're equal to each other. So with E2, obviously with all that we're going to have to do here, we need to think of our theorems, and the easiest way to remember our theorems is to remember Dr. Cape Town. If you're not familiar with Dr. Cape Town, there is a tutorial on this channel which is labeled Strategies to Approach Euclidean Geometry Riders, where we basically lay out the idea that you have to look out for things like diameters, radiuses, cyclic quads, parallel lines, and tangents to help you remember your theorems. But anyways, something that is equal to E2 is F1, because those are alternating angles. You see, because you have this line here, and then you have a line going up, and then it's a zigzag effect there, because this line is parallel to that line. So let's just state that, Okay, so I just had to correct something there. I had gotten a phone call saying that, bro, the sketch that you drew, that shape is supposed to be cyclic quad. This is all freehand, by the way, so it can be difficult sometimes, but is a cyclic quad that we're dealing with here. F, C, D, and G is a cyclic quadrilateral. So that does kind of make our life a bit easier, because I think it just brings out the whole thing. Because now if you look, F1 is equal to D2, because F1 is an exterior angle of this cyclic quad. Because if you look here, this is what we have, right? We have F1 over here and we have D2 over there. F1 is an exterior angle of the cyclic quad DGFC over there. So what we can say here is that D2 is equal to F2, because F1 is an exterior angle of the cyclic quadrilateral. So these two are equal to each other. It's purely a conclusion based on our findings. Yeah, that sketch, hey, is looking very, it is what it is. But anyways, on this sketch, we are going to answer the next two questions in the following videos. We are going to be answering this question. We are going to prove that AE, which is this line over there, is equal to square root of AD times AC. So if you're wondering where I got this question from, ta-da! I feel like you've heard me speak of this study guide already. But if you haven't, well, hello. ISO is our recommended study guide. The idea with this study guide is that it basically covers like the grade 10, 11 work before diving into like the grade 12 work. So the big idea is, if you need to get yourself, or if you want to get your hands on this study guide, you can get it on our website. The link to that is in the description. Two ways to get it. You can either just buy the book and we will ship it to you for free, or you can get the all access pass once off for the year, and then we'll throw in this textbook 100% free. We'll also ship it to you for free. I think you get the idea. But anyways, that's where I got this question here, which is the question we're about to work on in the next video. So I'll catch you in that next video. But before you do go there, don't forget to like, don't forget to do what again? Comment. In the comments, you can always ask me questions, like depending on whatever it is that you have questions on. So yeah, don't forget to like, subscribe, wada. Let me just look at this question.